Today we're going to talk about linear inequality in two variables. Last time we solved linear system of linear equations, and we discussed that in two variables or three variables, it's just intersection of lines or planes together, and we were looking for that intersection. Linear inequality in two variables, we might need to use those system of equations if you have more than one inequality. So in this case, we start with simplest case. Let's say if you had something like x squared minus x less than 3. This is linear, is an inequality, but it's not linear inequality actually. It's a non-linear inequality. And the way we wanted to solve this, if you remember, the steps were: first you change it to equal, you find the solution. X would be, let me change this to 0 or something. X would be 0 and 1. You'll get these two solutions. Then you draw the number line. You show these solutions 0, 1. You pick test point. You'll see this doesn't work, that will work, this will work. So therefore, this would be our solution would be in these two sections. System, if you want to solve linear inequality in two variable, it's kind of almost the same steps. You follow the same procedure. The only difference is when you draw it, the solutions is to this equation. So here, let's focus on this example: 3x minus 2y less than 6. If you wanted to solve this inequality, 3x minus 2y less than 6. Think about this. The question is, for what x and y is this inequality is a true statement? That's what we were focusing on. First step, I will try to do the same thing. Change the inequality to equal sign. This is what we did for nonlinear equations in one variable. So I changed this. And second solution would be, the second step was to find the solution. And draw them on a number line or graph. But what is the solution to this equation? 3x minus 2y equal to 6. This is this equation of a straight line. So we want to figure out where is that straight line, 3x minus 2y equal to 6. What is the solution? 3x minus 2y equal to 6. You can figure out what is y. Y equals, subtract 3x from both sides, divide by -2. You will get 3 over 2x minus 3, I think. If you subtract, you'll get, yes, if you move the x's to the other side and divide by -2, you will get this equation. Why do I write it this way? This is the point slope form. What is the y-intercept? Y-intercept must be -3, it's constant with the y-intercept. And what is the slope? Slope is 3/2. That means if I move 2 units to the right, 3 units up, actually you'll end up on the x-axis. End up at 2. 2 units right, 3 units up. Rise over run. Okay, so you'll end up at 2. Draw a line going through these 2 points. What does this line represent? This is exactly 3x minus 2y equal to 6. So I graph the solution to the equality. This is the second part. Find the solution. I found the solution. What is the third step? Third step would be to pick test points. This is what we did on the number line. We pick test point here, in between, and on the right side, in each section. If my solution is in the xy space, the inequality, if the solution to the inequality is in the xy space, your test point has been, this space has been divided in 2 pieces by that straight line. It would be either the left side space or the right hand side space. So each line breaks up the space into multiple sections. We want to find out where is this solution? Is it on the left side of the right line or the right side of the line? So what we pick is we pick test point in each section. Okay, for example, here I'll pick a point on the left side, as well as I'll pick a point on the right side. These are my test point. Let me pick a different color. Red. Okay, so this is a test point. Pick a specific coordinate, -1 and 1, for example. Just make sure it stays, your test point is correctly on the left side. And on the right side, I'll pick something like, here is an easier one. I'll pick 3 and 0 on the right side of the line. And you replace these test points into the original inequality to see if it satisfies the inequality or not. Replace -1 and 1 into the inequality. -3, 3 times -1 minus 2 times 1 is it less than 6. I replace this test point into the inequality. 3 times -1 is -1, -3. Minus 2 times 1, minus 2. Is it less than 6? Yes, it is. Therefore, this test point is acceptable. If you try 3 and 0 and replace 3 and 0, what you get is 3 times 3 minus 2 times 0. Is it less than 6? Say this is not true. 9 is not less than 6. So this point does not work. And these test points are just a sample of whatever number that you pick on the left side. All the numbers on the left side now satisfy the inequality because they will have the same, they will end up with the same structure as you got for this inequality. You'll end up with the same result. If you pick another number in this section, you'll say that this is going to be true every other number. So what you get is the solution actually is every number on the left side of that line. So what do I say? When they say graph the solution set, you do not write the solution by intervals. You draw it and say, this is the shaded area is the solution. So let me make it more clear. Draw it better. You draw the line, that line, to -3. And what is the solution? The solution would be everything on the left side. Normally you shade it in the online. There is an option to pick this, which side is the solution. The left side is the solution. There's only one thing that you should be careful. Is this a strict inequality or you have the option to equal? If it is strict, remember on the number line, if you had x less than 5, less than 1, for example, you couldn't pick 1. You would use open circle. You'd say parentheses. In this case, since it's strict, what changes is that means you cannot accept this line that you draw. So what do you change? Is you change that line to a dashed line. It means the line itself is not a part of the solution. Everything on the left side is acceptable, the line is not acceptable. If you had the equality option, that means the line would have been acceptable. Then I will draw the line solid line. The line is a part of the solution. That's the only difference, that if you have strictly less than or equality option as well. So here's one more example. Let's try this one. Graph the solution to this equation. Lift this up a bit. Okay. 4y less than or equal to 3x. First, step 1, change the inequality to equal. 4y equals 3x. Isolate y equals 3/4x. This is the equation of a line. What is the y-intercept? Y-intercept, x is 0. What is the y? Y is this constant here. In this case, there is no constant. 0 and 0. The origin, where they cross. What is the slope? Slope is 3/4. So can I graph that line? is line goes through 0 and 0 through the origin, 3 unit right, 4 unit up. Draw the line that goes through these points. Decide from this point, decide is it solid line or a dashed line. Look at the inequality. Since you have the option of equal, therefore I should use a solid line. So I draw a solid line that goes through these 2 points. Why didn't I? It's always difficult to draw a line through the points. Maybe I should draw the line first and put the points in. Okay, so which section are we going to accept? Is it left side or right side? We don't know. You pick a test point in each section. I'll pick a test point on the left side. Doesn't really matter where you pick it. I'll pick something easy that I can guess. Here is the point I pick is 0 and 1. And on the right side, I'll pick a point something like 2 and 0. These are my test points. Replace it in the inequality. I'll go back to the inequality. So the test points. I picked 0 and 1. Let's try 0 and 1. Four times 1, is it less than or equal to 3 times 0? 4 times 1 is 4. 3 times 0 is 0. Is 4 less than or equal to 0? Not really. So this didn't work. If you try the other point, 2 and 0. 4 times 0, is it less than or equal to 3 times 2? 0 is less than or equal to 6. This is true. Therefore, this point 2 and 0 is acceptable. So what is my solution? Everything on the right hand side plus the line itself. So the line plus this right hand side is the solution. That means whatever point that you pick on the right side, there's something like 5 and 2. If it's on the right side of this line, it should satisfy this original inequality. It doesn't matter what the point is. All these points satisfy that inequality. Try 5 and 2. 4 times 2, is it less than or equal to 3 times 5? 4 times 2 is 8. Is it less than or equal to 15? Yes, it is. 5 and 2 works. But on the other side, if you pick a number here on the left side, something like -1 and 3, it doesn't satisfy the equation. 4 times 3 is not less than or equal to -1 times 3. This is not true. It doesn't work, right? So the solution is basically, you don't need these test points. After, if you want to draw it, you just need to shade that area. You don't need to. The test points are just for you to decide which section is the correct section. So what do you show is this shaded area is the solution. Everything on the right side. It's not complicated as long as you draw the line correct. So here is what was important. What we learned about the system of linear equation was that you had 2 lines and they would intersect. You will figure out this point. System of linear inequalities means you still have 2 lines, and for each one you would have a shaded area. What you're looking for is the intersection of the shaded areas, and you're looking for this something like that satisfies both inequalities. Next, what we're going to talk about is this: what if you have 2 inequalities and you want to figure out what is the solution of those inequalities at the same time? This is what we call system of linear inequalities. First, x less than or equal to 1 and y greater than 2. Let's graph each one. What is x less than or equal to 1? Assuming this is 2 variables, it's not 1 variable. So I still have the x and y axis. Can you draw x equal to 1? X equal to 1 in 2 dimension. This is 1. X equal to 1 was a vertical line. So this is the vertical line, x equal to 1. Y equal to 2 is at 2 you would have a horizontal line. Change it to a different color. Alright. But since the inequality is strict, I'm going to use dashed line. This is the line y equal to 2. Okay. What does x less than 1 means? It means everything on the left side of 1, everything on the left side of 1, and y greater than 2 means everything above 2. This is in case if you deal with vertical and horizontal line, you don't need to go through all those test points. You can simply just check. And what is the intersection of all these shaded areas? What satisfies both at the same time is this area. Above 2 and left of 1. So this is our solution. Above 2 and left of 1. Okay. The line x equal to 1 is acceptable, but the line y equal to 2 is not. That's why we picked y equal to 2. You had strictly less greater than 2, x equal to 1 had the option of equality. But the first line was solid, the second line was a dashed line. This is the system of linear equation if you're dealing with vertical and horizontal line, but it's not always that easy. So most of the cases you would deal with something like this one. Okay, we have space, lift this up. So we want to find the solution to this inequality, which means find each one separately and then take their intersection. So I'm going to assume that I don't know this is a system. I'm going to solve each one separately. I'm going to solve y less than negative 1/3 x plus 1, and then solve negative 2x plus y less than or equal to 1. Solve each one separately. At the end, take their intersection of the each shaded area. Okay, let's deal with the first one. Change the inequality to equal. Y equals negative 1/3 x plus 1. What is the y-intercept? Y-intercept is at 0, 1, 1. What is the slope? Negative 1/3. I can do the same for the other line. Negative 2x plus y equal to 1. Solve for y. Y equals 2x plus 1. What is the y-intercept? At 0 and 1. What is the slope? Write the slope up front. Slope is 2. Okay. So graph each one, each line. I'm going to graph them maybe a bit down here. Slope negative 1/3, y-intercept 0, 1. So 0, 1, that's the y-intercept. 0, 1. Slope 1/3. Move 1 unit right, 3 unit up. So you'll end up at 1 and 4. 4 to 1. 1 and 4. Starting from 0, 1, you move 1 unit right, 3 unit up. Oh, was it 1/3 or 3 over 1? Sorry. Oh, negative 1/3. Sorry. Let's make sure that I don't make mistakes. There we go. Negative 1/3, this is rise over run. Rise over run. Means move 3 units to the right and 1 unit down. Sorry. 3 unit right, 1 unit down, you'll end up at 3 and 0. That's what I almost messed it up. So now the line goes through these 2 points. Do I use dashed line or solid line? I go back to the inequality. This is strictly less than, so I use dashed line. If I can draw this line better, I would have done that. Okay. And let's draw the other line as well. Then we pick test point in each section. I'm going to choose a different color. Okay. For the other one, slope is 2 and y-intercept 0, 1. Y-intercept still at 0, 1. They always, not always they have the same y-intercept. We're lucky at this point they have the same y-intercept. Slope is 2. Was it 2? Yes. You can write 2 over 1 if you want. 1 unit right, 2 unit up. So 1 unit right, 2 unit up, you end up at 1 and 3. So I use solid line or dashed line, you have the equality option. Therefore I use solid line. This is how that line looks like. Okay. So I draw each line. Now I have to figure out where is the solution. Okay. At this point, you have multiple choices. You can solve each inequality separately, or you can say now I have 4 sections. I have this section, I have this section, this one, and that one. So what do I need? I'll pick 4 test points and replace it into the inequalities. Or you can say let's solve each inequality separately. So what do? I'll pick for the red one, ignore the green, and for the red one, use the inequality. So let's pick test point. Here I'll pick something like 0, 0 and 3, 0. This is my test points for the red line. Pick 0, 0 and 3, 0 as the test point. These are the test points. Test point on each side of the line. One above, one below. Okay, so replace 0, 0 into the inequality. 0 is less than 0 plus 1. This is true. This is 0 less than -1 plus 1. Oh, this was 0 and 3. 3 and 0. 0 and 3. Is 3 less than 0 plus 1? Not true. So that means 0, 0 satisfies the inequality. This one worked, the other one didn't. So what do I accept? I'll accept this area for the red one. How about for the green? For the green, you can pick test points again. What you pick is a number on the right of the green line, one number on the left of the green line. Again, you can pick the same points. It is possible. One is on the left, one is on the right. 0, 0 is on the right, and 0, 3 is on the left. So I'll use the same test point. 0, 0, 0, 3. You replace 0, 0 in the inequality. Get -2 times 0, which is 0, plus 0. Is that less than 1? Yes, it is. If you try 0 and 3, get -2 times 0, which is 0, plus 3. Is it less than 1? This one is not correct. So 0, 0 works, 0, 3 does not work. So 0, 3 does not work. This guy didn't work. 0, 0 works on the right side of the line. So where is the intersection? That's why I didn't want to draw it over each other. But now you see that the intersection is both were satisfied the red and the green is this section. Below the red line to the right of the green. This is the area. The solution to that inequality is everything in this shaded area. If you use computer, it's much easier because you see how the lines are actually intersected properly. It's shaded, and my drawing is not that good. Okay. Any inequality, any system of inequality, if it's 2 of them, 3 of them, you do this. You just pick test points, find out where is the intersection, where it satisfies all those inequalities. If it was an OR, here, this means satisfy both. If this was OR, then your solution would be everything. It would be this part, that one, and this one. Satisfy either one is good enough. But for system of equation, that means you want to satisfy both at the same time. It's an AND case. So you're looking for the intersection, not the union. So the solution will only be this highlighted part. Okay, this is the inequality as well. Here's what you should be careful. Figure out exactly where is the intersection of two lines by doing the system of equation. In this case, we didn't really need to. But when you draw it, it's important to figure out where is this point as well, the intersection of the lines. Okay, I'll stop at this point.